Okay, in Chapter 8, we're going to take a closer look at the routing tables. In our previous chapters, we looked at the routing table using the show IP route command, and we saw how directly connected static and dynamic routes are added and deleted to the routing table. When you become a network administrator, it's important to know the routing table in depth when troubleshooting network issues. Understanding that structure and lookup process of the routing table will help you diagnose any routing table issues, regardless of where they occur, and believe me, you will have them at times. In this chapter, you're going to take a closer look at the routing table. The first part of the chapter focuses on the structure of Cisco's IP routing table. Keep in mind it's Cisco's IP routing table. You'll examine the format of the routing table and learn about level 1 and level 2 routes. The second part of the chapter, you're going to analyze the lookup process of the routing table, and we'll discuss classful routing behavior as well as classless routing behavior, which has the no IP classless and the IP classless commands. Routing behaviors and protocols are two different things, so keep that in mind. Many of the details regarding the structure and lookup process of Cisco IP routing table has been omitted in this chapter, and it would be covered in another chapter or in other books if you want to look for it. In this chapter, you're going to use a simple 3-router network. It's what we're going to discuss and use as our examples throughout the chapter. Here's what the topology looks like. This is the basic setup for router 1's config and router 3's config. Yes, we have 3 routers, but we're just looking at router 1 and 2. Some of the router table entries. Here's a sample, and you'll see you got directly connected networks, you have static routes, and you have dynamic routing protocols. The source of the route does not affect the structure of the routing table itself. So this is just an example of what we're going to be looking at. Routers 1 and 3 already have their interfaces configured with the appropriate IP addresses and subnet mask. And we'll now configure the interfaces for router 2 and use the debug IP routing to view the routing table process that's used to add the entries. Okay. So here we have on R2, you have your interface, your IP address. We have a clock rate set on this one. And you'll notice that since we had it set up on R1 and R3, we changed to an upstate. And we see that we have, with debug on, it tells me that it's added it. We have 0 metrics, and that the interface has been added to the routing table. Our level 1 routes, we can see those when we do show IP route, and it displays the directly connected network in the routing table. The Cisco IP routing table is not a flat database. The routing table is actually a hierarchical structure that's used to speed up the lookup process when locating routes and forwarding packets. Within the structure, the hierarchy includes several levels. For simplicity, we're going to look at level 1 and 2. So we've just split the table in half. With the level 1 route, it's a route with a subnet mask equal to or less than the classful mask of the network address. So if our network address is 192.168.1.20/24 is a level 1 network route because the subnet mask is equal to the network's classful mask. And remember, the classfuls are the 8, 16, and 24s. So at level 1, you have a default route, and that is a default route is a static route with the address of 0.0.0.0/0. It has a supernet route of 192.168.0.0/24 and a network route of 192.168.1.0/24. You have what's called an ultimate route, and the level 1 route of 192.168.1.0/24 can be further defined as an ultimate route. And an ultimate route is a route that includes either a next hop IP address rather than the path, and or an exit interface. Okay, so you'll see on this one it says 192.168.1.20/24 is directly connected to serial 001. We have parent and child routes with classful networks. Here's our parent. It is the top. It's where and it tells you it's subnetted into one subnet. And guess what? That one subnet is the child. Parent and child routes continued. A level 1 parent route is a network route that does not contain a next hop IP address or exit interface for any network. And a parent route is actually heading that indicates the presence of level 2 routes, also known as your child routes. And your level 1 parent route is automatically created anytime a subnet is added to the routing table. In other words, a parent route is created whenever a route with a mask greater than the classful mask is entered into the routing table. And the subnet for level 2 is the child route itself. And level 2 route is the route that is subnetted, is a subnet of a classful network address, as we see here. And if you'll watch this, it will explain this information here. This figure shows the configuration of serial 000 interface on router 2. Okay, the routing table shows 2 child routes for the same 172.16.0.0 parent route. Okay. Here's the router output when we did show IP route. That's the parent, that's a child, and that's a child. Because both child routes have the same subnet mask, the parent route still maintains the /24 prefix. Here's the level 1 parent route. Child, child, child. One more time. Next, let's look at the steps in the route lookup process. In this topology, RIP v1, a classful routing table, is now configured. And notice that we have specifically chosen a classful routing protocol with a discontiguous 172.16.0.0 subnet. So here is our configurations: router 1, router 2, router 3. Here's router 1's IP route, router 2's, and router 3. Some of the things you need to consider is what happens when a router receives an IP packet, examines the IP destination address, and looks that address up in the routing table. How does the router decide which route in the routing table is the best match? What effort does the subnet mask have What effect does the subnet mask have on the routing table lookup process? How does the router decide whether or not to use a supernet or a default route if a better match is not found? So let's look for the answers. Let's go through the steps. In step 1, we're going to examine the level 1 routes for best match with the packet's destination address. Then, if a best match is a level 1 ultimate route, use it to forward the packet. If the best match is a level 1 parent route, we'll go to step 2. In step 2, child routes are examined for a best match. Oops. Match. Use this subnet to forward the packet. No match, then we'll go to step 3. In step 3, classful or classless routing behavior. Classful routing behavior, drop the packet. Classless routing behavior, search level 1 routes. Which match with supernet or default. Use it to forward the packet. Supernets are checked first, then the default if necessary. No match, no default, the packet is dropped. You can look for the longest match, and the term best match was used in the previous route lookup discussion. What's this meant? The best match is also referred to as the longest match. Okay? The route with the most number of equivalent leftmost bits, or the longest match, is always the preferred route. Let's watch this in action. Classful and classless routing behavior. Like I said earlier, they are not the same thing as routing protocols. Classless and classful routing behaviors are not the same as classful and classless routing protocols. Classful and classless routing protocols affect how the routing table is populated. Classful and classless routing behavior determines how the routing table is searched after it is populated. In this particular figure, the routing sources, including classful and classless routing protocols, are the inputs used to populate the routing table. The routing behavior, specified by the IP classless or no IP classless commands, determines how the route lookup process will proceed at step 3. We have a little bit of topology changing here that we're going to look at. So pay close attention as we go forward. We now focus on step 3 in the route lookup process, namely what happens after step 2b when there is no match on any of the level 2 child routes of the parent or the parent. Later you'll see a specific example. Okay, so step 3, is it classful or classless? And 3a, Classful routing behavior drops the packet. When you do show running config, you should see a no IP classless, or it will say IP classless. In our routing table lookup process, step 3.8 states that when classful routing behavior is in effect, the process will not continue searching level 1 routes in the routing table. If a packet doesn't match a child route for the parent network route, then the router drops the packets. Okay, it's parent, child, child, child. Okay. See, there are no matches in the children. As you recall, in the routing table process in steps 1 and 2, the routing table process examines level 1 and 2 child routes, looking for the best match with the IP packet's destination address. Let's assume there is no match and resume our review of the route lookup process with step 3. Okay, it determines if it's classful or classless, and that's in behavior, not protocol. Classful routing behavior, the packet is dropped. If it's classless, the search level 1 begins to search level 1 routes. You match with a supernet or a default, and you use it to forward the packet. Supernets are checked first, then defaults if necessary. If there is no match at this location, then it is dropped. We have our routing table, we have our parent, child, child, child once again. Okay. Because we're using classless routing behavior, or IP classless, the router continues searching the routing tables beyond the parent route and its child route. The routing process will continue to search the routing table for a route with a subnet mask fewer than the 16 bits of the previous parent route. In other words, the router will continue to search the other routes in the routing table where there may be fewer bits that match but still match. Okay, so here's our new network. Here's our default route, our forwarding packet, our routing table. You've been assigned the lab for investigating the routing table lookup process. The Show IP Route Challenge. Be sure to go over the summary and review both sections. I've also assigned the Packet Tracer Skills Integration Challenge. Don't freak out over it. It's going to cover everything that you've learned up to this point, but it may not give you specific details on how to complete it. And take your chapter quiz so that you prepare yourself for the exam.